Alright, so we're integrating 2y to the negative fifth with respect to dy. So looking at the book, we can take out that 2, that's that constant multiple rule that it talks about. And then from here, I'm using a power rule. The power rule, kind of like when you do a derivative, you subtract 1 from the exponent. Well, with the integration rule, you add 1 to the exponent. So if I add 1 to my exponent, instead of negative 5, I'd have negative 4. But to make sure I don't get rid of, that I get what I want, I also have to divide by that number. The rule says do an n plus 1, so your exponent plus 1 up top, and do the same thing on bottom. Because the idea is, if I were to take the derivative of just this piece, I would multiply it by negative 4, so that would cancel out, right? Those would cancel out, and I would subtract 1 from my exponent, which would give me that negative 5. So the rule says you subtract 1, or you add 1, for integration, you add 1 to our exponent of negative 5, and you divide by that number. So when I added 1 to negative 5, I got negative 4, and then I immediately divide by that number. Lastly, with our integration step, we need to add some constant, because again, on the other video I showed that it doesn't matter if it moves up or down, those slopes are still the same. So I could simplify if I wanted to, and I could say, hey, this is negative 1/2 y to the negative 4th plus c. And that would be my answer for that first problem. The second one we looked at, I believe, have some root symbols in it. So let's do something like that. I was integrating the square root of x plus 1 over 5 root x. Again, this is with respect to x, the dx. So I had suggested on the earlier video to change this to rational exponents. Alright. And one of the other rules that we can use as basic integration rules is the sum rule. I can break these two things up. I can say this is the integration of x to the 1/2 with respect to x, plus breaking this one out, and I'm going to go ahead and pull out that constant. So that's using that sum rule for integration. So now I'm going to use the power rule. This is where I add 1 to the exponent, and then I immediately divide by it. So if I add 1 to 1/2, I get 1/2, or 3/2, and I divide by 3/2. Plus, there's my constant. Add 1 to the 1/2, which would give me positive 1/2, and then divide by 1/2. And then lastly, a big old plus c. You could simplify this just by multiplying by the reciprocal. So that would be 2/5 x to the 1/2, and then plus c. You can always check your work. Again, this is my antiderivative, my big F. Always check your work by taking the derivative of this. If you take the derivative of this, you should get back this, what we had before we integrated. And the last one was the word problem. So that was number 9 that I wanted to look at. And so in number 9, we had this marginal cost, right, of 1 over 60x plus 18. So this is the derivative. It was the dc dx. So I want to integrate this. And so now I'm going to use those techniques that we just used. I could split it up. Now, don't let me forget my with respect to dx on each one of these. So this one looks a little different. Remember, there's a 1 up there. So I add 1 to it, and then I divide by that new number. Now this one, when you have a constant, what was it before? So try to think backwards. If you just have a constant, it would be 18x, because the derivative of 18x is 18. And then lastly, we would have that plus c. So this is my antiderivative, right? So if I have a marginal cost, a derivative of a cost, this is just becoming my cost function. Again, that c is just some arbitrary c. I'm going to call it d for a second, just because I don't have the same variable. So I'm going to call it d, just some constant. And so here's my cost function. Now they told me my fixed cost when x was 0, so c of 0 is equal to 1,000 was my problem. So this equals 1,000, so let's plug in zeros. So this piece, when I put in x equals 0, is 0. This piece is also a 0, plus d, so that means that constant that I added was 1,000. So now I can write my full cost equation. It's the 1 over 60. We could simplify a little bit. With that 2 on the bottom, it would be 1 over 120 x squared plus 18x plus 1,000. So this would be the cost function that we started with.